All right, this is part 2 of the videos for section 9.1. All right, so in the first part, we talked about inference, and hopefully you have a better understanding of what statistical inference means and what inferential statistics is referring to. We also talked about calculating a point estimate for a population proportion. We said that p hat is x over n. And now we're going to talk about constructing a confidence interval estimate for a population proportion. And mostly we're going to focus on the calculator function and when we're able to use it. All right, so the first thing we want to do is make sure that we can use the calculator function 1prop z int. And the main thing that we're checking for is this idea of this z. So z is the same thing as thinking back to z-score, which means we are using a normal curve. And we have a few things that we need to check before we can officially just throw our numbers into the 1prop z int and assume that it's going to give us a correct interval. So the first thing we have to do is check to make sure that n times p hat times 1 minus p hat is greater than or equal to 10. So this simply means, let's see, what was the example we had? We had a sample of 200 people who had taken a particular drug, 10 milligrams per day of a particular drug, and we had a sample proportion, a p hat, of 0.18. That was in our first video. We found those values, or we found the p hat value, and so I would need to make sure, does 200 times 0.18 times 1 minus 0.18 give me a number that's greater than or equal to 10? And this is just a quick check. Once I type it in my calculator, 200 times 0.18 times 0.82, or you can even just type in times 1 minus 0.18, I'm going to get 29.52, and that is in fact greater than or equal to 10. So I need to check that. The other thing I need to check is that my sample size and my population size are appropriate. And remember that capital N is what we use for our population size. So we wrote that down in chapter 3 notes, I believe. And then, of course, lowercase n has been what we've been using for sample size for the entire semester. And what we need to make sure of is that the sample size is no more than, so no more than means not greater than, which would be less than or equal to 5% of the population size. And we actually used this before. We used this when we wanted to know whether or not something could be treated as independent. So even if we're doing, we're taking people, we're going to survey 1,000 people, and when we take those 1,000 names and randomly select them, we're not going to throw a name back in and then select again. We're just going to pick a name, and then we're going to pick a name, and technically we're choosing from a smaller total population. We're subtracting 1 each time. But remember, when we took a small enough sample from a very large population, it would have been very rare for us to have seen that and gotten that same person back out a second time. For us to double choose someone if we had done it with replacement. So if you might remember this from chapter 5, I hope you do, this is what we were doing. We can use this and we can treat it as if it were independent samples or independent sampling. And of course, with our 200 people who were taking the drug, we can assume that there were plenty more. That 200 is a very small sample coming out of all the people, either of the country or who need that drug. Whatever our population is, this is plenty small enough for us to say that we can use this normal curve. All right, so you have a calculator sheet in Momentum. It's under Content, and then chapters 8, 9, and 10. And then there's a calculator sheet for chapter 8, and then a calculator sheet for chapter 9. And so this gives you actually 3 different functions for coming up with confidence interval. One of them is for confidence interval for a proportion, and it is 1 prop z int. And there's 2 main things that I want us to see here. The first thing is that it's got this word prop. Prop is short for proportion. Once we get to the test over chapters 8, 9, 10, and 4 that go together, so this test 3 that we're going to have at the end of the semester, you're not going to have section 9.1 homework that's all on proportions and section 9.2 homework that's all on means. And so you may not know right away, just based on the section that you're working on, which function to use in the calculator, but this tells us if we're dealing with a proportion, if we have a percentage or a proportion, then we're dealing with a 1 prop z int. The other thing I want us to see is that this says int. Here in just a second on the next screen, I'm going to pull up the calculator, and int is for interval. And so there's also a 1 prop z test. That's not going to do us any good right now. So we want to make sure that we're doing the 1 prop for proportion, z interval. All right, so here's our trusty calculator, and I'm going to, like I said, you've got this in your content on the calculator sheet, but I'm just going to go through the steps real quick to show you how to get to 1 prop z int. Now, first of all, of course, we're going to use this stat button right here. That's where we're going to start. And then from there, we will go through the calculator or the buttons to push. So once we go to stat, that's where we've gone before to put in our list. We can hit edit. We've also used the calc menu already to do our 1 variable statistics. But we're going to go one more over to tests. And again, notice all these tests here at the beginning. That is not what we want. We don't want these tests right now. We want to scroll down and go to the ones that say interval. So notice interval, interval, int. That's what we're looking for, because what we need is to be able to find a 1 prop z int. So there we go. Option A, 1 prop z int, and this is super easy. We just have 3 things that we need to put in. We need to put in our x value, our n, and our confidence level. That's it. And then it will give us the confidence interval that we are looking for. Now, I'm not going to go through an example right now on this, but what we'll see here in a bit is that we're going to end up with 3 things. And I'll draw kind of what that screen will look like. You'll have an interval, and I'm just going to put random numbers. So there we go. 0.123 to 0.456. And then it's going to give you a p-hat. And in this case, that should be something like 0.2895. That's that point estimate. And actually, how do I know that? I know that because my point estimate is going to be halfway between my 2 numbers. So what I did there was I actually added one 0.123 plus 0.256. I divided by 2, and that gave me my p-hat value. And then it's going to give me my n, and I totally just made this up, so I don't know. Let's say our n was 2,000.